The 1918 influenza pandemic killed 50 to 100 million people, spreading gradually around the globe before it began to grow exponentially. The vast majority of infected people had a typical influenza-like illness without complications, but 2% experienced the sudden onset of lower respiratory involvement that progressed rapidly. I'm Stephen Morrissey, managing editor of the New England Journal of Medicine, and I'm talking with David Morens, senior advisor to the director of the National Institute of Allergy and Infectious Diseases. Dr. Morens has co-authored a perspective article about the 1918 influenza pandemic and our readiness for the next severe pandemic threat. Dr. Morens, can you tell us a bit about the virus that caused the 1918 pandemic and what we've learned about it in recent years? In what ways did it differ from other influenza viruses?
Every pandemic virus is a new virus. If it wasn't new, it wouldn't cause a pandemic. And every pandemic virus is different from every other. But what we do know about this virus is that shortly before it became pandemic in 1918, it had been a virus of wild birds, waterfowl such as ducks and geese. This is the reservoir of all influenza A viruses. And somehow, through some unknown leap, a completely normal virus of wild waterfowl that has existed in waterfowl for centuries or millennia jumped or switched into human beings to become a human virus. That virus was eventually sequenced genetically. It's an RNA virus, and the whole genome was sequenced. And we know that it's very wild bird-like, meaning that we know it's very much like viruses that occur in wild birds today. The genetics of it are a little bit different, and something about it was different enough that it could leave wild birds and get into people.
You write in your article that the virus went undetected as it spread, and it was killing at a rate of about 1% to 2%. Would the seriousness of a similar threat be identified earlier today? Are our tools better now?
Yes, our tools are much better now. For example, back in 1918, mortality data, that is statistics about people who die in countries and cities and what they die of, were not very well established. Most nations didn't have sophisticated national data. Nations that did have good data tended to have good data in big cities, but not in other parts of the country. And of course, in 1918, we didn't know what the cause of influenza was. We didn't even know it was a specific disease. So people who did die of what was surely influenza in 1918 might not have been diagnosed correctly by their physician. The report wouldn't have been made in a mandatory fashion to a state health department as it would be now. And all sorts of things could be going on in the background with people dying, and we wouldn't necessarily know the extent of the problem or what the cause was. Nowadays, in the developed world at least, we have much better national data on the causes of death. And were this to happen again, in the United States at least, we'd be on top of it very, very quickly.
So then, what's the evidence that a pandemic as severe as the 1918 influenza pandemic could occur again?
Well, there's at least two reasons to think that it could and will occur again. One is we have historical records of pandemics going back more than 1,200 years, and we can recognize them as being probably influenza back that long ago because of the epidemiology, how quickly they spread, where they spread to, the types of illnesses, the causes of death, and the risk groups of human beings that died, young people, old people, pregnant women, people with chronic diseases. This has been the same throughout history, and when we see these patterns back in the past, we can be reasonably certain that this is influenza and not some other disease. No other disease has the global epidemiology and clinical appearance as influenza. The other thing we know now, though, is that the particular virulence or pathogenicity of the 1918 virus is due to genetic peculiarities or genetic factors that come right out of the wild bird viruses. And those same viruses and the genetic factors are there in nature today. So that doesn't mean that they will come out and cause a pandemic tomorrow or next year or even 10, 20, 100 years from now. But the bad parts of the virus, the bad things in the virus that harm people, were there in wild bird viruses back in 1918. And because the viruses don't drift or change genetically in birds very much, they're still here today. That's been shown experimentally in experimental animals, so that we know the same bad factors, if you want to call them that existed in 1918 still exist in nature today, and they're likely to exist for many years, hundreds if not thousands of years into the future.
So how was the 1918 pandemic ended?
Well, it hasn't ended yet. The 1918 pandemic, in many ways, is still going on. And I think of it as the 1918 pandemic began a viral era, or a pandemic viral era, with a founder virus, the founder virus being sort of the first immigrant virus to get into people. And all the influenza A viruses that have occurred in human beings since then, in every single year for 100 years, every season we have them. We know in the Northern Hemisphere, in America, for example, we have seasonal flu. The flu comes back every year. All of those viruses are descendants of the 1918 virus. They've been updated by various genetic tricks, but they still contain parts, viral parts that are derived from 1918. So in many ways, the pandemic has never gone away. It's just evolved, and its ancestors are still killing us. Moreover, if you look at the last 100 years, about 3 times or 4 times as many people have died of the descendant viruses and seasonal flu than died in the pandemic itself in the first 2 or 3 years of 1918 and 2 or 3 years after.
You talk in your article about several lessons that can be learned from the 1918 pandemic, including the need to optimize our therapeutic and preventive armamentarium in order to prevent death from secondary bacterial pneumonia. Are there any promising avenues that are being explored in that area?
It depends on how optimistic you are. There are no magic bullets. There are no cures for influenza. We have antiviral drugs that are moderately effective, and some new drugs coming online are being developed. But those have to be used early, and they're not curative. They may improve the course of the illness, but they're not going to cure one if one becomes ill. Of course, we have antibiotics, and the antibiotics are effective against many of the bacteria that killed people in 1918 and would kill people today. But the problem is that the course of disease of influenza goes so quickly, from a minor illness with headache and stuffy nose and sometimes fever to bronchopneumonia, a particular deadly type of pneumonia. That happens so quickly that unless antibiotics are given early, they may not be effective. They may not cure the person. Bronchopneumonia is a particularly bad thing that by the time you realize you have it, or by the time the doctor realizes you have it, there's a very short window of time to get a person into treatment, ideally in a hospital, ideally in an ICU, and administer antibiotics through an IV. So if you think about most of us, we have a doctor, and we go to our doctor, hopefully, and we have to ask ourselves the question, when we get a cold or when we get a flu-like illness, how quickly can we see our doctor if we make a call and say, I need to be seen? The answer is not always instantaneously. So if millions of people in the United States were sick at once, practitioners wouldn't be able to see people to evaluate them quickly enough. And of course, many people will get flu, but only a small percentage will go on to die. And there's no way to tell early on which group is which. So that's a particular problem. Also, I would add a third one, that some of these bacteria that killed people in 1918 as secondary invaders after the viral disease of influenza, some of those bacteria we have vaccines against, particularly pneumococcus, but others like streptococcus or group A beta hemolytic like strep pyogenes, and staphylococcus, including MRSA and all the other types of staphylococci, we don't have vaccines for those. And so people with streptococcus, for example, 20 to 50% of all people carry them around in their nose. And they're just harmless until such time as an influenza virus or another respiratory virus gets in and damages the lining of the respiratory tract. Then those harmless bacteria in the nose are down on the lung very quickly, and we haven't prevented it, and we have to be very quick to be able to administer antibiotics to treat it before it gets out of control.
Finally, you also talk in your article about the need for a universal influenza vaccine. So how close are we to having that, and what are the challenges involved in getting one?
Let me answer your question as in an easy fashion as possible. We're not close to having a universal vaccine. A universal vaccine is a loose term that means something that works against all influenza virus, and it works very well. We're not close to having one, and I doubt we're going to be close anytime soon. The big roadblock is that we don't understand the fundamentals of what scientists and physicians call the natural history and pathogenesis of the disease. So we don't know what it is that the influenza virus does as it goes through various cells in our nose and throat and eyes and into our ears and then down our respiratory tract and into our lungs, encountering various tissues and various parts of the immune system that would allow us to design a vaccine that could fight the battle where it needs to be fought. And the other aspect of it, if you think about it, the whole breathing tract, the respiratory tract, your windpipe, all the way down into your air sacs of your lungs, are really on the outside. They're in contact with the air, but they're external. They're on the outside in the same way that our skin is on the outside. We don't think of it that way because we think of breathing air inside of us, but we don't really breathe it inside of us. We breathe it into our lungs, which are an invagination or an interning of our outside. But the immune system is on the inside. So the problem with influenza and respiratory viruses is the bugs are entirely on the outside, but the immune system is entirely on the inside. And they don't have any place where in a normal circumstance they encounter each other in a substantial way. So the challenge we have for those respiratory viruses that don't get inside the body, which is many of them, most of them, we've never been able to make a really effective vaccine to any of them, not only flu, but all the other ones as well. And it's a fundamental problem of how to engage the immune system to fight a battle in a place where it is not against an enemy that's in a different place.
Thank you, Dr. Morens.